Describe and explain are two words that can strike fear into the heart of any biology teacher, because they are two very different questions and they are far too often confused by students. So we're actually going to start this lesson of describing and explaining graphs by going back to your syllabus. And what do your examiners actually mean when they ask you to describe or explain? So, an instruction that says describe in any kind of question in IG Bio is very simply asking you to give the main points. Whether you are describing a process or describing a data collection in a table or describing a graph, you are stating the main points. If you are asked to explain, it's different. Okay? Explanations are giving reasons why. So here they are expecting you to give reasons. Biologically important reasons, not just ideas which you have that may or may not be true, but here we're linking it to the theory that you're learning. Okay? And it's quite interesting that in the syllabus they say specifically, leave your examiner in no doubt about what is going on. So you must leave no doubt as to why something in particular is happening. Okay, so what is that something in particular? That's your description. We are describing that this is changing. Why is it changing? What's the details behind it? So a describe is just what I'm looking at, and explain is why is it happening? Why is it doing that? So obviously, one of the things we can look at in this way is a graph. And there's a few key things to think about when you're describing and explaining graphs. And what we're going to do is we're going to have a look at it sort of in general, and then I've got some past paper questions lined up that we can go through in a bit more detail. So let us give us a graph to start off with. So a random graph, and we're going to break our graph into three little pieces. We have this piece, oh, not three, four, sorry, that piece, this piece, and this piece. And what each of these is doing is giving you a different thing that you might see. Okay, so what are these different things that we're looking at? Remember, of course, that we have our independent variable on our horizontal axis and our dependent variable on our vertical axis, and that most likely has units because it's been measured. So even when we're looking at these graphs in our theory papers, multiple choice or our short answer question, we've got the same relationship of independent and dependent going on with our graphs. So what do we see when we look at this graph? The first piece we see, let's call him section A. Section A is showing you that a graph can increase. Okay. Section B. It's quite interesting that our graph stays the same. It doesn't go up to a point and down again. He stays the same. So if you see a flat piece on your graph, we are talking about an area that remains the same. So that is another interesting piece. And what you're doing is you're trying to collect what are the interesting pieces of my graph that I'm going to talk about when I describe it. So the next phase of our graph is C. And what we see in C is we see the opposite of A. Now our graph is decreasing. So we would explain, or we would describe that our graph is simply decreasing. Now this other wiggly bit at the end here, not always spiky, sometimes it's rather a wobbly one, but it goes up and down and up and down and up and down. And it sort of stays the same but goes up and down. There's a lovely word to use for that. This zone, we can say that it's going to fluctuate. So it can fluctuate around a particular value, or it can fluctuate between two particular values. But when it goes up, down, up, down, up, down, and it's sort of wobbly and it's not really straight, then fluctuate is a lovely word to use. So these are all descriptive words, okay? There's a few more that you might want to bear in mind, okay? See, our graph went up all the way to a certain point, and it didn't go above there, okay? So you would want to relate to it, if you have one, the fact that you might have a maximum value. Also, we started at a value down here, okay? We didn't get there at the end, but we started there, so we also had a minimum value. So whenever you have a maximum value or a minimum value, those are also interesting pieces on your graph. Okay, so the other thing, right? We had this line going up and this line going down. Okay, but what if we had something, sort of a variation on that? We could have a line that goes like this and like this. Or it could go down, and then it could go down, like that, then down like that, then down like that. So there's all sorts of different kinds of ups and downs. So here we talk about sharp or steep increases or decreases. We also talk about gentle increase and decrease. Okay, so let's put a little note by increase and decrease to bring you down here as well. So what have we done here? Okay, all we've done is all of these things are about descriptions. So this is going to be a very colorful slide. We have simply described what our graph is doing, okay? The other thing, of course, if we had values on here, because it goes from a minimum of 10 to a maximum of 60 meters per second, okay? It remains at 60 meters per second until 40 minutes, and then it goes down. So you see, we're adding in data. So the other thing we want to always do when we're describing is to use data values. So you have to be able to read the scale on your graph, which is also why it's so important that you get that practice of making graphs. So when you make graphs and you build scales, then it's also building that skill of being able to read somebody else's scale. Okay, so this is how we describe a graph. Yes, we've got everything. So different zones of the graph, what is interesting on our graph, and all we're doing is saying it goes up, it stays the same, it goes down, it fluctuates, it goes down steeply, then it goes down gently. Okay, we're just talking about what we see. We're stating the main points that our graph is showing us. If we then came to explain would be why. It goes up because. It stays the same because, then you get your explanation. So a description is, it goes up, it goes down. Whenever you then put a because, you're linking to an explanation. So we can ask to describe a graph, we can be asked to explain a graph, or we can be asked to describe and explain a graph. In which case, we've got to do both of them together. If you're only asked to describe, you do not explain. If you're only asked to explain, you do not describe. If you're asked to do both, you do both. And it's really important that you follow those instructions very carefully. Okay, so the other one that they like to sort of throw things in is if they put two graphs. So let's say if you have for two graphs. So, for example, we have one that looks like this. So we've got two data sets on here. okay? 2 different types of enzymes, or 2 different temperatures, or 2 different groups of people doing exercise, okay? So there, you're doing exactly the same. You're still describing, but, okay, you're looking out for, in particular, similarities and differences. Do they both increase together? Does one increase before the other one? Do they have the same maximum or different maximums? And that's what you're pulling out when you are comparing 2 graphs. Exactly the same description points as we've worked on here, but taking those description points and saying, okay, so my 2 graphs, do they do it together? Do they do it differently? What are the similarities and differences? Are we cool? Can we do some past papers? So we've got here a selection of different questions from all sorts of different topics in the syllabus. Okay, first one, we have a drug, domifene, is given to women who have difficulty in having children. The drug increases the secretion of FSH. As part of a treatment for infertility, a woman was given domifene for 5 days. The concentration of estrogen in her blood was measured every day for 27 days. The results are shown in figure 3.2. And you might be sitting there saying, but I haven't done this yet. I don't know this yet. How is she teaching me this now in a live lesson? Well, the thing is, figure 3.2 is a graph, right? We've got time in days on the bottom. We can see when the domifene was taken, and then we can see the concentration of estrogen in the blood in arbitrary units. So look at the question. The question just says, describe the changes in estrogen in the blood over the 27 days. Doesn't say, what is FSH and what does that do to estrogen? Okay? You don't need to have a theoretical understanding here. You're not asked to explain. You are just asked to describe. You could give this to a 10-year-old and say, describe the shape of this graph. And they say, up, down, up, down. That's it. Okay, so that is where you need to be, even to do graphs on topics you haven't studied yet is fantastic, because if it's a description question, you're not expected to know that explanation. So what do we see? We see a graph, we see time, we see concentration, okay, we see up, down. So now let's turn that into an answer. First thing is, if we want to describe, we need to give data values. So we need to understand what's going on with our scale. Okay, so if we look down here first, we've got 1, 2, 3, 4, 5 little blocks, and we have 2 days, which means that halfway at 2.5 blocks would be 1 day. Okay, so we can now understand the scale here. On the left-hand side, we have 20 units. Okay, but that is also 1, 2, 3, 4, 5 blocks. So 20 divided by 5, we have 4 units per block. So now we know we're sorted with how we're going to read this scale. Okay, sometimes in these biographs, particularly in the short answer paper, they use weird scales. So even if it looks like a straightforward one, it's always worth double checking to say, you know, what are you actually counting in? Okay, so we're going up, well, from day 1 all the way up to, where does this one fall? Okay, let's take this all the way down. This is to day 11. We're going up. Now, obviously, if you're doing this on paper, you've got a ruler and you're being accurate. I did do it on paper first to make sure. Okay, we come down. Okay, where do we come down to? Slightly more accurately on screen this time, 15. Then we go up again, and we have a beautiful, another little maximum, not as high as the first one, at day 20. Then we come down again, all the way to 27, which makes sense, because they said it was measured for 27 days. Now we do the same thing, get some numbers for our concentration of estrogen. So we said 4 units is 1 block. So here, as we come across, we have 20, 24, 28, So this would take us to 30. And we're not caring about so much these values in the middle because they're just not these features of interest. So across the top, we come to 4 below 160, 156. So the query has come in whether this reading here should actually be 32. If we zoom in a bit, because that is the joy of teaching on a screen, you can see that this one is actually in the middle of this block here. So this little line under here, the computer doesn't like it when we zoom in, would be 28. This line above it would be 32. So because we're in the middle of the block, we need to read to that 30. So let's zoom out again so that my computer is a little bit happier. All right, so we went up to 156 on that line. We come down here, see, to another middle of the block. So if we take across this middle of the block, okay, now we are 6 below 60. Okay, because we're one full block and one half block, so that makes 6. So 60 minus 6 gives us 54 arbitrary units. And where do we end off? This final reading on day 27 is where we're going down to. And that brings us straight across to 40. So now we've got a really good understanding. We're going up from here to here, down from here to here. And we can start to turn that into sentences, which we can use to describe. 4 marks, 4 zones. It's looking like we're going to be okay with this one. So, this changes in estrogen. So do we care about where the start is? Not really, because we care about the change. So, estrogen increases from day 1 to day 11 to a maximum. Remember, we said maximums are nice. Of 156. We always give our units whenever we take readings off. Okay, units here are arbitrary units, which means there's just some random unit and we don't need to worry about it, but that is the unit, so we need to write it 156 arbitrary units. Okay, so increasing from day 1 to day 11 to a maximum of 156. From day 11 to day 15, we're going to decrease. All the way down to, and we said this one here at the bottom here is 54. Arbitrary units. So what happens next? We increase again. So from day 15 to day 20, estrogen increases again. But remember, we're increasing up, but we're not going as high as that first time. So we don't want to go to another maximum, okay? But we can say it's a peak, but it's lower. So to a lower peak of, what was it there? That's the one we didn't read, ladies and gentlemen. Shocking. Across here. So we're on this line. And we are, so 1 block below 140, so 4 below 140, so we're on 136. So our lower peak is actually 20 units lower, 156 down to 136. So to a lower peak of 136 arbitrary units. Okay, then we've described up to day 20. They want us to describe all the way over the 27 days. So what happens next? Well, from day 20 to day 27, we decrease again. So estrogen decreases again from day 20 to day 27 down to 40. Remember, we went across here, at the bottom of here, all the way across straight onto 40. Arbitrary units. Now I want to show you something very funky, right? We've just described what we're seeing. And what's very cool, it's only worth 4 marks, right? But they mark these so nicely. Increases from day 1 to 11, 1 mark. Maximum of data point, 1 mark. Decreases day 11 to day 15, 1 mark. Down to 54, 1 mark. 15 to 20 increases again. Peak of 136. Decreases again down to 40. 1, 2, 3, 4, 5, 6, 7, 8 ticks. We are definitely getting our 4 marks. And that's why these description questions are so nice, because there's often many ways in which you could get that description. Now we can see that we don't have much more time left, so we're going to continue with the other 3 graphs in 2 weeks' time when we do skills again, because I'd rather spend a little bit more time doing these properly and making sure that you really understand how we're getting the describing, the explaining going on, because of course, we've done a description graph, we're going to have some explaining graphs to do as well. So are we all happy now with the idea and the concept behind describing a graph? We are simply looking at the graph and saying, it's going up, it's going down, it's staying flat, maximums, minimums, fluctuations, all these different vocabulary words that we can use just to say what are the main points that we are describing from this graph if we are just asked to describe.